In this video, we're going to look at trigonometric functions with the quotient rule. So always with the quotient rule, what we do is we write down what the top and the bottom differentiate to. Top differentiates to 1 and the bottom differentiates to, and here we have f of x and f prime x, and inverse sine of x over a becomes 1 over the square root of a squared minus x squared. And you can see here that a is the bottom and x is the top. So a squared is 4 minus x squared, x is the top. So the quotient rule, dy dx, or f prime x is equal to, on the bottom we're always going to have the bottom squared, so the inverse sine of x over 2 to be squared, that's the bottom squared. And then on the top we always start with it's the bottom by the top differentiated, which is the inverse sine of x over 2. Now I'm going to put the 1 in, but it's not going to change the value, and so it's the bottom by the top differentiated, and then minus the top by the bottom differentiated, which is x, multiplied by 1 over the square root of 4 minus x squared. I should have given myself more room. So then to tidy this up, we can just put the x on top, or we could multiply everything by the square root of 4 minus x squared. So if we multiply everything by the square root of 4 minus x squared, we're going to get the square root of 4 minus x squared by the inverse sine of x over 2 minus x, because this is going to put a square root of 4 minus x squared on top, so we're just going to get minus x over the square root of 4 minus x squared by the inverse sine of x over 2 to be squared. Be careful at this point not to think, oh, I can cancel the square root of 4 minus x squared here, because there is a 1 in here. The reason we've multiplied by it is to have this x on its own. So that's, in its simplest form, that's the answer to this question. So this one, y is equal to x squared over the inverse cos of x over 3. The top differentiates to be 2x. The bottom differentiates to be, you can see here, it's minus 1 over a squared minus x squared, so minus 1 over a squared, which is 3 squared, which is 9, and the minus x squared. So now we just simplify it down using our quotient rule. On the bottom, we're going to have the bottom squared, the inverse cos of x over 3, the whole thing to be squared. On top, we have the bottom, the inverse cos of x over 3 by the top differentiated, which is 2x, minus the top, which is x squared, by the bottom differentiated, which is 1 over the square root of 9 minus x squared. So tidying this up, don't forget your minus in here. So tidying this up, we're going to put the 2x in front, 2x by the inverse cos of x over 3. This minus and this minus are going to give me a plus x squared over the square root of 9 minus x squared, all over the inverse cos of x over 3 to be squared. Now if I tidy this up, I'm going to multiply everything by the square root of 9 minus x squared to get rid of it. So I'm going to get the square root of 9 minus x squared, it's going to go in here, times 2x times the inverse cos of x over 3. Then I'm going to just have plus x squared, because I'm going to have a square root of 9 minus x squared top and bottom, and then that's all over the square root of 9 minus x squared by the inverse cos of x over 3 to be squared. Just that's the whole thing. So that's this one tidied up as much as it can be tidied up. Let's have a look at another one. So this one deals with tan. Differentiate each. The top becomes 1. Just double check always. Tan, you're going to see here is, we don't have a 1 on top this time, we have an a on top. So it's a, which is the bottom, over a squared plus x squared. So a, which is the bottom, so 4 over 16 plus x squared, a squared plus x squared. It doesn't matter whether it's x squared plus 16 or 16 plus x squared, but keep the same order. So we follow our quotient rule. On the bottom, we're going to have the bottom to be squared, the inverse tan of x over 4, all to be squared. On top, we have the bottom, which is the inverse tan of x over 4, by the top differentiated, minus the top, which is x, by the bottom differentiated, which is 4 over 16 plus x squared. So tidying this up, we're going to have the inverse tan of x over 4 minus 4x over 16 plus x squared, all over the inverse tan of x over 2, all to be squared. And if we multiply everything by 16 plus x squared, we're going to get 16 plus x squared times the inverse tan of x over 4 minus 4x on top, all over 16 plus x squared by the inverse tan of x over 4, not x over 2, which I've put in here, x over 4, all to be squared on the bottom. Because the brilliant Ed McEntee has requested this video, I'll do a couple more. So this one, y is equal to x cubed over the inverse sine of x over 3. X cubed goes to 3x squared. And the inverse sine of x over 3, this is the one's positive 1 over the square root of 9 minus x squared. So applying our quotient rule. On the bottom, we have the bottom squared. And on top, we have the bottom by the top differentiated minus the top by the bottom differentiated. And tidying this up, we're going to multiply everything by the square root of 9 minus x squared. So we're going to get the square root of 9 minus x squared by the inverse sine of x over 3 times 3x squared. So I'm going to put this 3x squared in front here. Now we're going to have minus x cubed all over the square root of 9 minus x squared by the inverse sine of x over 3, all to be squared. And Ed, your confusion might have come from the answer in the book or the solutions being incorrect. This is the correct solution to this question. Let's have a look at two more. This one, y is equal to the inverse sine of x over 2 divided by x plus 1. The top differentiates to be 1 over the square root of 4 minus x squared. The bottom, x will just differentiate to 1. So following our quotient rule rules, the bottom squared, x plus 1 to be squared. On top, we have the bottom, x plus 1 by the differentiated top, which is 1 over the square root of 4 minus x squared, minus the top, which is the inverse sine of x over 2 by the bottom differentiated, which is just 1. Following the same procedures that we've done all the time, we want to get rid of that square root in the bottom, the 4 minus x squared in here. So if I multiply everything by the square root of 4 minus x squared, I'm going to get x plus 1 minus the square root of 4 minus x squared by the inverse sine of x over 2 on top. And on the bottom, I'm going to get the square root of 4 minus x squared by x plus 1 to be squared on the bottom. So this is the final one. The inverse tan of x over 3 differentiates to be a, the bottom, 3 over a squared plus x squared. So 3 squared, I'll just change it to 9. 9 plus x squared. And the bottom differentiates to be 3x squared. So our rules, the bottom to be squared, x cubed to be squared, which is x to the power of 6, is going to give us, that's the bottom squared. On top, we have the bottom, x cubed by the top differentiated, which is 3 over 9 plus x squared, minus the top, which is the inverse tan of x over 3, by the bottom differentiated, which is 3x squared. So there's a little bit more tidying up involved in this one. So tidy the first term up here, this one. I'm going to get 3x cubed over 9 plus x squared. I'm going to have minus 3x squared by the inverse tan of x over 3. And on the bottom, I'm going to have x to the power 6. Now, if I divide everything by x squared, which is the highest power of x, I'll be able to tidy it up a little bit. So imagine that there's going to be an x squared on the bottom here. So I'll be able to divide it into the x cubed. So I'm going to get 3x in this term, in the first one, over 9 plus x squared, minus the x squared will disappear if I divide by x squared. So I'm going to get 3 times the inverse tan of x over 3. And on the bottom, I'm going to have x to the power of 4. So multiplying everything by 9 plus x squared, I'm going to get 3x minus 9 plus x squared by 3 by the inverse tan of x over 3 divided by 9 plus x squared by x to the power of 4. And we could probably leave it like this, but I'm going to multiply the bracket on the bottom and the 3 by the 9 plus x squared. So we're going to get 3x minus 27 plus 3x squared by the inverse tan of x over 3. And that's all over 9x to the power of 4 plus x to the power of 6. And in case you're thinking about dividing by x again, you can see here this 27 doesn't have an x in it, so we can't divide everything by x, so this is fully simplified. So Ed, Sunday afternoon, practice these questions. Good luck with them.